Let me borrow somebody's computer screen that's on it. Thank you very much. Aria. All right. And it's not over there. There we go. Now we've got it up there. Can I go bigger? No, not really. Is that up to the top? Okay. Yeah. Okay, cool. What speed should a satellite of mass 4,900 kilograms moving around the moon be? What speed should it be at, I guess? Okay, it is worded weird. In order to stay in orbit, if the distance between them is 4.2 times 10 to the 9th meters and the mass of the moon is 7.36 times 10 to the 22nd kilograms, estimate G as our constant, which we've got. Okay. So first thing I want to say is, what are they looking for and what are we given? They're looking for the what of the satellite? The speed of the satellite. Do we have, based on what we're given, do we have what we need to get that directly? Like in one step. So this is probably one of those multi-step questions. It sure is. What have we been doing that we do have enough information for? What's that? The thing on the board. What would we be finding? What's the force of gravity? Gravitational force. We've been doing it like 10 times in a row, right? As far as questions. So I'm going to introduce you to a new formula. It's this one right here. It's FC. The C is for centripetal. So the centripetal force is equal to m, which is mass, velocity squared divided by radius. Do we have the radius? Yes. Yep, we got the distance there. Do we have the mass of the satellite? Yeah. So we'd be looking for the velocity. Cool, that's what we need. It says speed, so that works for us. But we would need that, wouldn't we? We'd need that centripetal force. How do we find that? Remember we talked about the balancing act. To hold something in orbit, in this case a satellite in orbit, that centripetal force has to equal the force of what? Gravity. If they're not the same, that satellite would either fly off away from the moon or it would crash into it, yes? So if centripetal force in this scenario must be the same as gravitational force, well, that means we can find that because we're given that, and then we'd have everything except velocity to solve that one too. Does that make sense? So go ahead and do me a favor. We're gonna work gravitational force first, which we've done a bunch lately. So let's go ahead and put those numbers in here, and then you guys can multiply across, divide down. We've got our two masses. One is the satellite at 4,900 kilograms. Forgive me if I don't put kg there. And we have the mass of the moon at 7.36 times 10 to the, what was it, 22nd? Yep. So multiply those together and also multiply by the gravitational constant, 6.67 times 10 to the negative 11. And once you multiply those three together, we divide by the distance squared. And the distance is 4.2 times 10 to the 9th meters. It's already in meters. Perfect. 444. That's fine. And that'd be in newtons because it's gravitational force. You got it. That's correct. Yep. If you didn't get that, you were the one that did something wrong. So you can hit the arrow up and see how you put it in. Probably some silly, simple mistake. How many of y'all got this? Good. Cool. Cool. Most of you. All right. Now, so if we have this for that, it also is this value. Cool. Let's set it equal to it. So we have 0.013636444 newtons is equal to mv squared divided by r. Well, we know r. It's right. Yeah, it's right there. Good. 4.2 times 10 to the 9th. We have the mass of the satellite, but hear me out. I don't want to put it in there. Not yet. Okay, I want, the way this is set up, we can solve for this whole chunk, can't we? We can solve for this, like the product of these two multiplied by each other. We can solve for that product. So we're going to do that first. How do we solve for this numerator? Perfect. We multiply the denominator here by the force. So go ahead and do that. No, it's just straight multiplication.
We got 5727306.66.
I lost you after the 57273.
06.667.
So like repeating, probably. Okay. So that now is equal to what? It's equal to mass times velocity squared, right? Everybody tracking what we're doing? Still? Well, I'll go over it. If you're start like, wait, how did we get here? Don't worry, we'll go over it when we're finished. So now, what was the question asking for? What speed, right? Speed is velocity without a direction, right? So we're going for velocity here. How do I get velocity by itself? Divide the mass out, right? We know the mass, yes? So we can actually put that in now. 4,900 kilograms on each side. And oh, by the way, this value here is actually a Newton, right? And a Newton is kilogram meter per second squared. Yes, exactly. When you divide down, you're just going to be left, kilograms go away. So you're going to have meters per second squared. So V2 is equal to what? Once you divide 1,168 point. Perfect. So 1,168.8. We could probably round up to 69, but that's okay. All right, and that's going to be in meters per second squared. Wait, what? Oh, you must have done like extra work.
I don't know. I did it the same way, but I put in the wrong number.
Huh. You jumped ahead? I don't know. That's one of those mysteries, like, wait, how did I do that? Because it worked. I don't know. Now what? Do the square root, yes. To get the square off this side, I get the square root of 1168.8 meters per second squared. And then the square on the meters per second squared goes away too, doesn't it, once you do that? So velocity equals 34.1919. And it'd be in meters per second then, because we unsquared it, right? And it's one of the answers? Does that mean maybe we did something right? All right, hold on. Before we check it to the machine. You did already? That's fine. That's fine. We're going to walk through what we just did, because this is a lot of gobbledygook now, right? How many of y'all look at this and you're like, oh my goodness, that's gobbledygook. So I'm going to walk through what we did step by step. All right. First, we had to understand like some relationships. That balancing act, we have to understand that the force, the centripetal force, has to be equal to the force of gravity between the satellite and the moon. Otherwise, if it's less, it would fly in. If it's more, it would fly out, right? Okay. So because we know these two would be equal, we know we're going to use this formula because I told you, right? So So to get this value, we had to use the formula we've been using to find gravitational force. Do you track that so far? So we put in the masses, we put in the distance, we made sure we squared it, and we just solved. So we got that, and we used that gravitational force as the centripetal force because we know it has to be the same. So we put that here. And then we said, well, we're going to leave this numerator alone because we have the r, the radius, distance, so we can solve for this whole piece. So just by multiplying, we got this whole piece. That's this number. So we set it equal to mv squared because that's what it is. Then we divided out the mass, which we were given, and we got this number equal to velocity squared. But we don't want velocity squared, we just want the velocity. So we did the square root of that number to get the velocity by itself at 34.2 meters per second. Yeah. I can't. All right, so hold on, I just clicked on that. You can see she got it right. All right, let me click off of hers and find yours. Where are you? Okay, so I'm looking for Weissel or, oh, there's Helton. So you're on this one too? Same one? Yes, no, maybe?
Yeah.
Okay. Oh, yeah, that one, so we could work it, or we could just say, hey, we remember what the acceleration due to gravity on Earth is because we used that number for so long. What was the acceleration due to Earth's gravity? 9.8 or 9.81. All right, so there's slight variation. Is there a number on there that's really close to it? 9.79 is ridiculously close to 9.8, isn't it? Now, could we work the math if we wanted to? Yeah.
I got it right.
But I am lazy, so if that's what's handy about just knowing some things.
I didn't know that's what it was asking.
Oh, okay. Well, that's why it says, what is the acceleration? All right, cool. Good. I think the rest of them you guys should be able to handle. Yes. This one right here?
Yeah.
Yeah.
Why would we divide the 49?
So,
Yeah, because I thought the moon was just
no. So the question was asking how fast the satellite has to go.
Oh, I thought it was the moon.
No. Yeah, so we had to find the gravitational force between the moon and the satellite, but that goes both ways, right? But this formula helps us answer the question, which was how fast does the satellite need to be going? So the mass we put in would be the mass of the satellite. Good. It's questions like that that let me know that you all are tracking. I like questions like that.